So now we're going to look at the quadratic form. And if you recall from our work in exponential models, we've seen quadratic form before. For example, in the form 3 to the 2x plus 3 to the x plus 2 equal to 0. We did a little substitution with u, letting u or m or n or whatever letter you wanted to represent that linear term, and we're going to do the same thing here. So I'm just going to rewrite my function. And you know what? It might be that you can see the factoring right in the equation without substituting. So you can skip this part, but I'm going to let u equal the sine of theta. And I'm going to rewrite this as 2u squared minus 3u plus 1 equals 0. So that might help you see the factoring piece a little easier. Oopsie, that's not going to be a plus, that's going to be a minus. 2u minus 1 and u minus 1 equal to 0. So we get u equal to a half, u equal to 1, but then we're going to substitute that value, that sine theta, back in. So we're solving the equations, those simple trig equations. Sine theta is equal to a half, and sine theta is equal to a 1. So again, we still want to consider the quadrants where sine theta is positive. That's going to be in quadrants 1 and 2. And over here, this is going to be one of our quadrantal angles. So from the little mini equation sine theta equal to a half, we have values of theta at pi over 6 and 5 pi over 6. And sine theta is equal to 1 up at pi over 2. So that will be all of the solutions in the interval 0 to 2 pi for that. So we're going to do the same kind of factoring here, and if you recall, I asked you to go in and change that. That was originally a 3, but I asked you to change that back into a 2. So if you didn't get a chance to do that, you can do that now. And we're going to let u equal that tan theta. And so our equation becomes u squared plus 3u plus 2 equal to 0. So for this one, we're going to need a calculator for part of this, because in our factored form, u plus 2, u minus 1, we're going to get tangent theta equal to negative 2 and tangent theta equal to 1. And I'm going to do this equation right here. This one's straightforward from the unit circle. Tangent is positive in quadrants 1 and 3. Our reference angle is pi over 4. So in the first quadrant we have an angle of pi over 4, and in the third quadrant we have an angle of 5 pi over 4. So that's just part of the solution. So I'm just going to flip over to another slide and pick up from here. So we're going to focus on this equation right now, and again, like I said, we're going to need our calculator. So I'm going to start by recognizing that tangent is going to be negative in quadrants 2 and 4. So once I address the quadrant issue, I don't care about this negative sign anymore, and I don't want to use that in my calculator when I find my reference angle. So we are going to take an inverse tangent, but I'm going to ignore that negative because my reference angle, if you recall, a reference angle is going to be a first quadrant angle that we use with the symmetry of the circle to find the rest of the solutions to the equation. So I'm going to keep this as a positive angle, and here's my reference angle, and remember this is already in radians. So I'm going to round it to 3 decimal places, and let me write that down over here. So my reference angle is 1.107. So I need 2 angles now. I need the angle pi minus 1.107. So that's going to be one value of theta, pi minus 1.107. And then we're going to need the other angle, which is 2 pi minus that 1.107. And then you're going to use your calculator to finish off the rest of the solution. So let me do that real quick. You should, oopsie. One of your answers should be 2.035, and the other answer should be 5.176. So overall, the solutions for this part B equation should be the pi over 4, 5 pi over 4, 2.035, and 5.176. And again, use your calculator up here to check that those solutions satisfy the equation.